Hey, what up, guys? This is Ryan with Brainstorm. So, dividing rational expressions is actually, you're totally like not going to divide rational expressions. That's the thing about this whole section is basically when they tell you to divide rational expressions, the first thing you're going to do is get rid of this division sign. The division sign is annoying, so we're going to actually multiply by the reciprocal of this fraction. And here's the principle that this is based on, right? So if you had 1/2 divided by, right, 3/2. Do you remember, don't forget, there's a really important rule. If you ever divide by a fraction, it's the same as multiplying by the reciprocal, right? If I divide by 3/2, it's the same as multiplying by 2/3. And because of that principle, this whole section of dividing rational expressions is going to be kind of easy, right? And then now that I've multiplied by the reciprocal, right, then I can just cancel these 2's because they're same on top and bottom, and the answer is 1/3. Do not worry about division. Rewrite this immediately as a multiplication problem, right? And so if we look at this one above, it would be something like this, right? The first thing you're going to do every single time when you're asked to divide rational expressions is this. We're going to rewrite it, x plus 2 over 2x minus 1. Importantly, the first guy does not flip. We multiply by the reciprocal. It's the second guy, right? So now we have times, and all we do is flip this sucker, right? X plus 2. And if this looks cleaner to you, it does to me. I kind of like to picture these actually in brackets, right, like this. I don't know why. It just makes it so much more clear that these are individual terms, right? Now that we have this, well, can we cancel anybody? We totally can. Look, this whole guy here cancels this whole guy here, and you're left with, your answer would be 3x over 2x minus 1. I can't even imagine if you actually tried to like divide and all this stuff, right? So multiply by the reciprocal. All right, so then that would really send you back to the last video, which is on multiplying rational expressions, because if you're good at those, dividing is the exact same thing after you've made your flip. All right, so let's do a couple examples. Okay, so here's one. So remember, we're not even allowed to think until we rewrite this, right? So now we have 5x plus 10 over 4x minus 16 times 2x minus 8, right, the reciprocal, 3x plus 6. And now we can kind of go about the business of like factoring each term and then canceling where we can, right? It looks like the top, I'm going to bring this up here, right? It looks like the top, I can pull out a 5, maybe that's 5, and then it'll be x plus 2 over this guy. Looks to me like, well, what if I pulled a 4 out, right? So I had a 4, and then I'm left with x minus 4, so that's cool, right? Times, can't I pull a 2 out of here, right? So I'd have 2, and then I'd be done, be x minus 4 on the inside. And then this one, it looks like I can pull a 3 out of both, so I'd have 3, and then x plus 2. Okay, cool. And then that equals, remember, the next step is all you do is you cancel whoever's matching, which is cool. All right, it looks like this x plus 2 cancels this x plus 2. This x minus 4 kills this x minus 4. And then what about these numbers? They are individual factored terms, right? Can anybody cancel? I'm like looking at the 5 and the 3. No, the 2 and the 4. Wait a minute. The 2 can totally reduce the 4 to a 2, right? Because 2 into 4. And then now I guess I'm done. It looks like the only thing remaining on the top is a 5. And the only thing remaining on the bottom is the 2 and the 3. And yes, they multiply. So my answer would be 5, 6, right? That's pretty easy. All we do is multiply by the reciprocal, factor every single sucker, and then cancel like the wind, all right? So here's another one. Okay, you know, and as you get better at these, instead of just rewriting them flipped, you might kind of factor, and but don't even go there, right? So, okay, so this one, let's look at this. Again, we're not really thinking yet. We have x squared minus 9 over x plus 2 times the reciprocal, right? X squared plus 2x over this sucker here, x squared plus 2x minus 15. And now we can kind of factor. Again, I secretly knew that this was a difference of squares, so I could have done this step right now, which is x plus 3 and x minus 3, right? But why jinx yourself and make it overly complicated? So don't even bother to do that. Okay, so this is now I'm factoring. Actually, and if you look at the bottom, you really just can't factor it, right? I'm looking at it, and that happens sometimes. The term just stays the same, right? Times, okay, now let's factor these suckers. Looks like maybe I can pull an x out, and then I'm left with x plus 2. And then this one kind of looks like a traditional, right? It's a trinomial. It's a normal one, x and x. And it looks like multiplies to be negative 15, adds to be 2. I guess that would be plus 5 and minus 3. Okay, now let's see what our answer is. And if things don't cancel, right, if you factor a bunch and nothing cancels, you probably factored wrong, because the whole point to this is to multiply by the reciprocal, factor, and then cancel a bunch of suckers. Okay, so I don't know, it looks like this x minus 3 here gets this guy out of here. This is cool. We have an x plus 2 cancels him. This guy doesn't cancel him, and the x doesn't have any other x on the bottom to cancel, so I think we're done, right? And to write it, cool, you could write x plus 3 times x, but I usually do the little guy first, with no big deal. And then x plus 3 all over, it looks like just an x plus 5. And remember, this is your answer. Could we distribute the x? Totally. Then we would just have x squared plus 3x over x plus 5, which is correct, right? It really kind of just depends on what your teacher likes, right? So both these answers are right. Okay, you guys are getting cocky. Okay, let's do one more weird one, and if you get that one right, then you're justified in your self-confidence. All right, here's another one. Okay, perfect. Now, same thing, right? So we're going to rewrite this sucker and rewrite him as a reciprocal, right? Okay, so fine. X squared minus 6x. This, again, requires no thought yet, right? X squared minus 4x minus 12 times x squared minus 4x minus 12. This guy's now on the top, right? And then he goes to the bottom. X squared plus 5x plus 4. And now I'm kind of getting to the point where, like, look, I already know I'm going to factor every single guy, and a bunch of stuff is going to cancel out, and it's going to be happy days, right? So the top, it looks like x and x. Okay, multiplies to be negative 7, adds to be negative 6. It's totally minus 7 plus 1, you know? And yeah, every kid factors at a different rate, and some people are faster, some are slower. Don't even worry about it. Just take your time, factor, get them all right, and then some stuff will cancel, right? So don't feel bad that I'm like factoring fast and then other people, you know, whatever. You're just don't worry about it. Take your time, get them right. Okay, so this is x and x. Looks like negative 12 and negative 4 multiplies to be negative 12, adds to be negative 4, probably negative 6 and positive 2. Okay, and then times, right? Let's factor this sucker. What multiplies to be negative 12 and adds to be negative 4? That's the same thing, right? Wouldn't that be x here, again, and we would get, right? That would be minus 6 plus 2, okay, all over, right? This is kind of a normal one also. It looks like it would be x and x, okay. What multiplies to be 4 and adds to be 5? That would be 4 and 1, okay, plus 1. Okay, good. Now let's see what's going on. Let's check this situation here. Weirdly, this x minus 7 doesn't have another x minus 7, so nothing cancels there. That's a bummer. Okay, but x plus 1 cancels him. Looks like this x minus 6 cancels him, and then, okay, cool, x plus 2, x plus 2. What are we left with after the chaos, right? Well, this guy remains. X minus 7 is still here, and on the bottom, it looks like we're down to just the x plus 4, which is totally your answer. Can I cancel these x's? Of course not. They're not factors. This is x plus something, x plus something here. So no, this is your final answer. So that's really, don't even lie. This is like one of those things where you totally get it. Dividing rational expressions, we're not doing that. We're actually going to multiply after we take the reciprocal of the second guy. Then we factor away, and cancel a bunch of guys, and we're left with something. Hopefully that makes sense, and then I'm sure you guys will do fine in this section. All right, good luck.